Hi guys, welcome to my channel. Today let's solve yet other Leet code question. The description of the question is as follows. The distance of a pair of integers a and b is defined as the absolute difference between the values a, b. We were given an integer arrays nums and integer k such that we need to find the kth smallest distance among all the pairs that's possible. So for the first example given, the nums vector being 1, 3, 1, after sorting this, we'll get nums vector as 1, 1, 3, and here the differences are 1 and 1 difference gives 0, 1 and 3 the difference gives 2, and 1 and 1 again the difference gives, 1 and 3 again the difference gives 2. So first I computed this difference followed by 1 and this 3 difference, 1 and this 3 difference. So differences are 2. The first smallest distance is 0. And for the second nums, the given numbers of 1, 1, 1, I'll just sort the numbers out. Those again will become 1, 1, 1. The differences now are 0, 0 and 1, 1, 0. So second smallest distance over here as well is 0. And the third given nums are 1, 6, 1. So I'll just sort the nums. That would give us the nums as 1, 1 followed by 6. The differences are 0, 1 and 6 difference is 5, 1 and 6 again the difference is 5. The third smallest distance here is 5. So that's here. We knew that the minimum distance is nums of 1 minus nums of 0. The maximum distance is nums of size minus 1 minus nums of 0. So this is somewhat similar to, not somewhat, this is exactly how binary search works. We have the lowest value and we are also having the highest value. So at any given condition or at any given instance, we will check if we are till our k pairs or not, k pairs of smallest distance or not, and we will proceed accordingly. So that's how it works. First, I'll just have low. That would be nums of. Before doing that, I'll just sort this out as that's done as the starting step. Sorting the vector nums. So that would be sort nums dot begin followed by nums dot end. So low value here would be 0. High value here would be nums dot, or I'll just call and save size in other variable with name set. Low here would be nums of 1 minus nums of 0, and high here would be nums of size minus nums of 0. It should not be size, but it should be size minus 1. So I'll just iterate while my low is less than or equals to high. I'll just call my mid value to be low plus high minus low upon 2. And also here I'll do check, have a track of j and count. So why this j and count will be useful, I'll just tell you in a second. And I'll just iterate through all the numbers in this. And while my j is less than size and nums of j minus nums of I is lesser than or equal to mid, I'll just increment my j and count will become j minus I minus 1. So what exactly I'm doing here? So first I started at my 0th index and my j also will be 0. I'm just checking if my nums of j and nums of I while proceeding further is less than or equal to mid. Mid here gives us the difference. So I'm just checking if this pairs difference is less than or equal to mid value. If that's the case, then I can proceed for the further element and that difference also will obviously be less than mid. Sorry, that may or may not be less than mid because if you consider numbers as 0, 1, 2. Initially, my I would be at 0, J would be at 0. So here, let's suppose mid equal to 1. If I is 0 and J is 0, so if I computed the difference over there, then Ij will give me a difference 0. And if that's lesser than or equal to mid, in that case j will be incremented and j will be changed to 1. And in this case you could see j minus I, nums of j minus nums of I is again less than or equals to mid. Then again I'll proceed further and I'll just check j is equals to 2. In that case it won't be that possible condition, right? So how many pairs have we found? Starting from, we shouldn't include 0, neither we shouldn't include 2. Why we shouldn't include 0? Because nums I should not be equal to j. So 0 0 would not be the case, and also 0 2 would not be the case because that 2 is already out of bounds. So we are not including two elements, and we knew that between a and b, how many numbers would be there? B minus a minus 1, right? So if I give you an example as 2 and 5, how many numbers are there between 2 and 5? 3, 4. That's 5 minus 2 minus 1. There are two numbers, so that's 5 minus 2 minus 1. Again, if I consider number as 1 and 10, how many numbers are there between 1 and 10? The answer is 8, 2 to 9, right? 2 to 9 is nothing but 8 numbers, and that can be computed by 10 minus 1, that's 8. So I'm just incrementing my count here. After incrementing my count, I'll just check if my count is less than k. In that case, if my count will be less than k, then my mid would be, or low would be, mid plus 1, else my high would be mid minus 1. I'll just return low from it. Yes, it's working fine. I'll just submit this out. So it's not working for the ultimate test case. I'll just not consider going till equal to. I'll just check while my low is less than high, and here instead of making high as mid minus 1, I'll just make it mid, so that our bounds or our subspace will be divided into two parts. No, that's not the case. My lowest here, if I kept it as 0, then would it suffice? Yes, my lowest sum should be 0, not nums 1 minus nums 0. So I'll just keep it as it is. I guess this should not be the case. Yes, it's working fine. Let me just submit this out. So it's working picture perfect. I'll just also tell my compiler not to import any libraries. From CPP, I'll just tell my compiler that not to import any libraries that are required for taking input and giving output from my C into C++. That should be iOS based. Sorry for the error. So it's working great. Thank you. Feel free to add any doubt in the comment section. I'll just try to reply for it.